Right, now in this video, we want to evaluate some functions. Okay, so we are still in the course of functions. Right, so we want to evaluate the following functions. So we have from number 1 to number 6. Okay, anyway, let's continue. So for number 1 question, we want to evaluate that function f of x equals to something, right? So f of x is equal to x. We want to evaluate it first when x is 0, second when x is 1, and third when x is equal to 2. Anyway, let me skip that number 1 and number 2 for you, and then let's do number 3 first, right? Then I will come back to number 1 and number 2. Right. So let's start with the number 3. So let's say number 3 will be, this is 1, 2, okay, 3, number 2, and then let's start with number 3. Say f of x is equal to x squared minus 2, okay, when x is 4, 1, and 0. So what we'll be doing here is that we want to evaluate this function when x is 4. Then again, when we are done, we evaluate when x is 1, and then, okay, when x is 10. Good. What this tells us is that when x is 4, right? When x is 4, what that tells us is that x is equal to 4. See, in place of x, we can put 4, right? So in place of x, I'm just going to put 4. So that means in place of x right here, we can just plug in 4. That is what it is. Very simple. So since we've done that to the left-hand side, we're also going to replace x with 4 on the right-hand side. That means in place of x here, we're going to put 4. And then when you do that, remember x has been squared. So you remember to square that 4 and then subtract 2 from it. Alright, good. So we can evaluate this real quick. 4 squared is just 16. You subtract 2 from 16, you have 14 as a result. So 14 is the output, while 4 was the input. Okay, so in our last video, we talked about the input and the output, the domain and the range. So when you plug in 4 into this function, what you get out is just 14. And that's it. Right? Great. Alright, let's look at the first question. We look at f of x equals to x. When x is 0, when x is 1, and when x is 2. Okay, so with this information I've given you from the third question, you can easily evaluate when x is 10. Right, let me just do that for you. So when x is 10, then f of 10 will be... So again, in place of x, we just replace x with 10. So we'll do that to the right-hand side. That will give us 10 squared minus 2, right? 10 squared is just 100. And then subtract 2 from that, you get 98. And that is the result. Okay, for the first question, we have f of x is x. That tells us that whatever we have here will be what we will have as an output. Remember, the input is here. When we evaluate this, when we are done evaluating, that will be the output, as we discussed in the last video. Good. So f of something gives you that thing as a result. So if we plug in 0, that tells us that f of 0 will be 0. So f here just produces what you gave to it. It's just an identity, something identical. Whatever you gave to it, it gives you out the result. F of 1 is just 1, and then f of 2 will just be 2, right? So that is simple. Let's look at the second one. F of x is equal to k, where k is a constant. Great. This is going to be a little bit tricky, but it's the simplest actually. This k here is a constant, right? Maybe I didn't give us a point to evaluate this. Maybe let's evaluate this when x is equal to 5, right? So when x is 5, then that tells us that f of 5 will be... Now remember the same thing we did in the third question, when we're solving the third question. F of 4 is giving us, whenever we see x, we just plug in 4, and that is what we've done. So that means when we see x on the left-hand side, I've plugged in 5, so we should also plug in 5 for x on the right-hand side. Good. Oh, unfortunately, on the right-hand side, x is missing. That means we can't plug in x on the right-hand side because there is no x right there, alright? What we have on the right-hand side is just k, which is independent of x. So that tells us that f of 5 is equal to k. not 5k, because there is no x on the right hand side to plug in 5 for. Good. So that tells us that even if we plug in f of 10, it's still going to give us k. Plug in f of 100, it's still going to give us k. F of 1 million is still going to give us k as a result. So that function is constant, right? The graph goes this way. This is the x values that you plug in. This is the x, the negative x-axis. This is the y values, alright? So if you plug in 2, it gives you k. Let's say this is where k is. You plug in negative 2 here, it gives you k. You plug in negative 1, it gives you k. Plug in 0, it gives you k. Plug in anything, it gives you just k like that. So it's going to be constant throughout, right? But that's not a concern right now, this graph. But that's just for the second one. Great. Let's look over to the fourth function, and we just evaluate it immediately. So on the fourth question here, we have f of x to be all of that. So f of x is x cubed minus, let me bring it down a little bit, x to the power of 3 minus 2x minus 1 divided by, x squared plus 2. Right, let's evaluate this when x is negative 2 and, when x is negative 2 only. Good. Let's evaluate this when x is pi. Great. Okay, so when x is 2, right, so we'll be talking about f of 2, as we've done that earlier. So let me replace this 2 with the blue ink. Okay. So what that means, when x is 2, negative 2, so in place of x, we are just going to put negative 2 because we say x should be equal to negative 2. That is when x is equal to negative 2. So on the right hand side, we'll just plug in negative 2 for x, and then we're going to see that we'll have, so for x, we plug in negative 2, alright? This is x to power 3. We plug in negative 2 in place of x. Then x is being raised to power 3, so we raise that to power 3. Then we subtract it with 2 times x. Here, this is x, which we say should be negative 2. So I'm just going to put in negative 2 right there. And then we subtract 1 from that. That is just the numerator. Then the denominator, we go again, x to be negative 2. Then we raise that to power 2, right? And then we add 2 to that. This is 2. Okay, good. So that is just it, just replacement. And be mindful of where the power is. If it is just a negative number, that's why I use the negative number. Make sure the power covers everything, right? Good. So this gives us, now negative 2 raised to power 3. Maybe you can go ahead and check that out. If you don't know, that is just negative 8. And then we subtract it with 2 times. Now negative 2 times negative 2, that gives us positive 4. Good. And then we subtract 1 from the result. And then we divide everything there by, again, negative 2 is here. We raise that to power 2. Now, negative 2 raised to power 2 means negative 2 multiplied with negative 2. So negative 2 times negative 2 gives us positive 4. So we have 4 here, and then we add 2 to that. Okay, so in the numerator, we're going to have negative 5, and then the denominator, we're going to have just 6. So this gives us negative 5 over 6, which is even a proper fraction. That's a nice place to stop for that one. And then the question number 5, right? Question number 5, we have to evaluate f of x equals to 1 over x when x is 2, when x is 1 and when x is 0. Good. Now this number 5 question, let's just look at it. So f of x equals to 1 over x when x is 2, 1 over x when x is 1, alright? So when we have x to be 2, then f of 2 will give us 1 over 2, right? Because we just say plug in 2 in place of x here and do the same thing in place of x here. So in place of x, we're just going to put 2 right there, and that will give us just 1 over 2. So that's the result, right? Good. So let's evaluate if when x is 1. So when x is 1, we plug in 1 here, we plug in 1 here, that gives us 1 over 1, which is just 1, right? You know, this is 1 over 2, which is just 1 over 2. You can express it as in decimal 0.5. Good. Now let's look at when x is 0. 1 over 0. Does this remind you of anything your teacher must have told you once? That you don't divide by 0. That is, the denominator of fractions should not be 0. Good. So f of 0 gives you 1 over 0. But 0 is in the denominator, which is a problem. So why do you divide by 0? This is not defined. This is undefined, right? Now, in our previous video, we talked about functions. We talk about range. So when you plug in something, it gives you a result. The thing you plug in is called an element from the domain. That is the input. What you get out is, as a result, is an element from the range. That is the output. So if you plug in something and the result gives you this form, that is something over 0, where this something is not 0, then the whole result is not defined. We say it is undefined. And as such, this 0 here should not be an input of that function, since it does not give us a certain value, alright, as an output. So this should not be an input, and as such, this should not be in the domain. Anyway, in our next video, we're talking about domain of functions, and then we are going to see this real detailed enough, alright? Good. Great. So that thing is undefined. Maybe I can just spell it out for you. Undefined. Right, let's look at the number 6. We have f of x to be, this involves trigonometric functions, sine x plus cosine x over tangent of x over the whole of that. It doesn't even matter, alright? All that matters is whenever you see x, you plug in pi. Great. So we'll be talking about, I'm not going to write this out, right? I'm just going to evaluate it here real quick. F of pi, right, will be, so let's just look at that. F of pi will be, now, whenever we see x here, we just plug in pi. And let's do that and evaluate immediately. So, first of all, we have sine x. In place of x, we put pi. That is sine pi. So, it's now left for you to know what is sine pi, right? Sine pi. Pi in radians. This pi is in radians. Okay, is the same thing as 180 degrees, right? So, sine pi from our trigonometric tables, we know that sine pi is 0. Good. So I'm just going to plug that in there, 0. And then plus cosine pi, again, from our trig table, we know that cosine pi is going to be -1. So we just have it there, 0 plus -1, that is 0 minus 1. Good. Then on the bottom, we'll be talking about tangent of pi, which is still 0, and then divided by pi plus 1. So I'm just going to put it down there. Pi plus 1. Right? And then we subtract, say minus pi. This x is pi. So we say minus pi. And then minus 1 again. Good. Right. So you see what we've got? We've got 0 minus 1 over the whole of that. Great. Now it's now left for us to simplify this simple expression on the right side. We have 0 minus 1, which gives us -1. Okay, great. You're subtracting 1 from 0, from 0. That will take you one place to the left-hand side of 0. That is when we're talking about whole numbers. 0 over something, the result is going to be 0. When we have 0 in the numerator of a fraction, given that the denominator of that fraction is not 0, then the result will be 0. So this place is going to be 0, so we can just leave it like that, since this place is subtraction, right? So negative pi minus 1. Right, good. And we can cancel out the 1 on the top and the 1 on the bottom. That'll be 1. This minus will cancel out with this minus, and therefore turning this place to a positive sign. So we have that result to be 1 over pi plus 1 as an output for the number 6. Anyway, this pi is an irrational number. We cannot express it as normal numbers or as fractions. It is best left this way. So this is the output for that number 6 question. So from there, you just gain knowledge on how to evaluate functions, and that is what you get. Right, thanks for watching. Please subscribe to my channel.